All right, so free air delivery is given 14 meter cubes per minute. Free air delivery means at these free air conditions, T is equal to 1.013 bar, T is 15 degrees Celsius. Our actual conditions are different, that is 0.95 bar and 32 degrees Celsius as given in the problem. The delivery pressure is 7 bar. The pressure at which the gas has to leave this P2 is 7 bars. And the index of compression, it means this process compression and expansion are following this law PV to the power 1.3. So we need to find out the indicated power P and the volumetric efficiency. So here we cannot use the volumetric efficiency on the basis of actual conditions, because here free air delivery is given. So that's why we have to calculate volumetric efficiency on the basis of free air conditions. So what else is given? The clearance volume. This clearance volume, VC, is 5% of swept volume, means 0.05 of VS. That is also given of the swept volume. So total swept volume is VS. So this VC is given as 0.05 of VS. And this total volume starting from cylinder head till top dead center is VA, that will be VS plus 0.05 of VS, so that is 1.05 of VS. This is VS, this is 0.05 of VS, so this total is VS plus 0.05 of VS, means 1.05 of VS, that is VA. So that will be used later in this problem. So first of all, we need to calculate the power output. So that is the equation of power output. N over N minus 1, M dot R, T2 minus T1. Right. So first of all, we need to calculate M dot, because V dot is given, free air delivery. So M dot from the ideal gas equation. So here P and T are free air pressure and temperature, because this V is free air delivery. So that's why we shall use this P and T for free air conditions, divided by R, gas constant, which is air. So V dot is FAD, free air delivery at P and T. So values put kar de, 1.013 bar into 10 to the power 5 pascals ho gaya. That is V dot divided by 0.287 into 10 to the power 3, or 287, multiplied by 288 Kelvin. So this M dot corresponding to this free air delivery is 17.16 kilogram per minute. Now M dot is calculated. Next in this equation, we need to find out P2. So T2 is equal to P1 into P2 over P1 to the power n minus 1. Because this T2 here, this T2, from this law, this equation, right? Reversible polytropic. So for reversible polytropic, values put kar de, P1 is given 32 plus 273 P2 over P1. Okay, these are actual conditions which are to be taken into account, and this P2 is 483.6. So power output में आप values put कर दें, 1.3 N M dot, which is calculated on the basis of free air conditions, 0.287, 483. Okay, so that is the power output, 63.5 kilowatts. So this is the power of the compressor, which is delivering this mass. What is this mass? Based on free air conditions. Agar free air conditions या free air delivery ना given हो, then you have to calculate on the basis of real conditions. Right? Real conditions mean you have to calculate this M dot on the basis of P1 and T1 and VA minus VD, जो real induced volume होता है at that P1 T1. But here चूंकि free air conditions दिया हुआ, so corresponding to free air conditions, that is the power output. Sorry, power input to the compressor. Second, we need to calculate the volumetric efficiency. So here is the formula of volumetric, general formula, V over Vs, where this V is based on free air conditions, because the inlet conditions जैसे the inlet or inlet conditions during induction are different from the standard inlet conditions. Standard means free air conditions. So it means this V, swept volume is clear. Swept volume is this volume. That is a fixed. Now what is this V? We have to calculate this V corresponding to this P and T. And actual is P1 into VA minus VT over RT1 is made equal to PV over RT. So from here we calculate V, which is equal to VA minus VT induced volume into T1T over T1P. Agar free air conditions or actual conditions both are same, then this P1 will cancel with P, T will cancel with T1. So actual and free air conditions will be same. V is equal to VMI, but चूंकि different है तो उसका effect है that is compensated here. So that is free air delivery, this V, which is equal to VA minus VT into P1T over. So ये मैंने आपको बता दिया, inlet conditions during induction are different from the standard conditions. So free air delivery is equal to VA minus VT into TP1 over T1P. Now in this formula, from this formula, because this V is given 14 meter cubes per minute, actually we are trying to find out the VA minus VT from this formula. Okay. So now in this formula, we know what is VA. VA is given in terms of VS, 1.05 VS. Now we want to write an equation for VD from this curve, from this expansion curve. So VD is equal to VC into P2 by P1 to the power 1 over N from that reversible polytropic equation. VC is given as 0.05 of VS, clearance volume, into P2 by P1, which is the actual 7 over 0.95 to the power 1 over 1.3. So it is 0.232 VS. So this VD is now given as 0.23 VDS. So VA minus VD will be VA minus VD is 0.232 VS. And what is VA? VA is 1.05 VS minus 0.232. So that is VA minus VD. So that is 0.818 VS. So now put this equation, put this value of VA minus VD in this equation to find out actual V. Okay, free air delivery per cycle in terms of swept volume आपके पास आ जाएगा answer. Okay, VA minus VD in terms of swept volume, T over T1, P1 over P. All our known just values put करते हैं. So now we have V is equal to 0.724 of VS. Right, which is actually equal to 14 meter cubes per minute. So अब जो हमारा efficiency की equation थी, volumetric efficiency की equation, volumetric efficiency is equal to V over VS. So this V in terms of VS we have calculated divided by VS. So this VS will cancel with the VS, and that is volumetric efficiency 72.4%. Okay. अब जो हमारे पास दूसरा फार्मूला था, अगर हम यही वॉल्यूमेट्रिक एफिशिएंसी फाइंड करते हैं इस फार्मूला से जो हमने डिराइव किया था बेस्ड ऑन एक्चुअल कंडीशंस, नॉट ऑन द बेसिस ऑफ फ्री एयर कंडीशन बट एक्चुअल कंडीशंस, अगर इसी फार्मूले से भी हम वॉल्यूमेट्रिक एफिशिएंसी फाइंड करें तो व्हाट विल बी हियर वीसी वी नो 0.05 of VS over VS, P2 over P1 7 over 0.95. So इस फार्मूले से जो आंसर है दैट इज डिफरेंट 81.8 compared to when we are using standardized free air conditions. So that is the reason why the efficiency, volumetric efficiency changes as the conditions during induction stroke changes. और ये change कोई बहुत ज़्यादा drastic भी नहीं है, सिर्फ आपका pressure जो है that is dropped और temperature increase हुआ 15 की बजाय it is 32, pressure थोड़ा सा ड्रॉप किया है 90 का, ओवरऑल रिजल्ट के हायर वॉल्यूमेट्रिक एफिशिएंसी ऑलमोस्ट 10% का डिफरेंस आ रहा है. सो दैट इज द एक्चुअल वॉल्यूमेट्रिक एफिशिएंसी, दैट इज द वॉल्यूमेट्रिक एफिशिएंसी ऑन दिस बेसिस ऑफ फ्री एयर कंडीशंस. इससे आप यूज करेंगे टू कंपेयर this value with any other compressor of any other manufacturer. उसकी volumetric efficiency on free air conditions क्या है, उसकी basis पे you can tell that this compressor is performing better than the other one, or this particular compressor is better on the basis of free air conditions, right? अगर free air conditions कोई data यहाँ given ना हो, then you have to simply use this equation based on actual real conditions during induction cycle to find out the volumetric efficiency. Because this equation, this one, ignores the difference in temperature and pressure between the free air conditions and the actual suction conditions. Gee, any question? Okay. No question. So then I shall start the next topic, almost the last topic of this chapter, multi-stage compression. अभी तक हमने discuss किया single stage compression. It means only one single cylinder and one cylinder piston mechanism. It could be single acting, it could be double acting, but single cylinder. So gas is compressed in a single stage. So single stage compression जो हमने अभी discuss किया with clearance. So here we have seen that is the induction stroke, compression, delivery, and expansion. So let me name it as A, B, C, and D. That is top dead center, D, D, C. That is bottom dead center. And this whole volume is swept volume, Vs. And this volume is clearance volume. So induction, compression, delivery, and expansion. Okay, so that is the indicator diagram which we know now. So here is, for example, inlet pressure P1, that is outlet pressure P2. Okay. Now if we want to use the same compressor for higher pressure, okay. Higher pressure means the required pressure is till this one, P3. The same compressor is to be used to achieve higher pressures. It means that इसी fluid को during compression stroke, we want to compress it till this point, P3. And at this point, so this process will continue. What is this process? This process is following PV to the power N is equal to a constant. Now this is extended till this point. So the exit valve will now open at this point, not at this point. The exit valve is volume पे open हो जाता. Now this exit valve will open at this volume because we want higher pressure. So at this point, the exit valve is opened, so there will be delivery till this point, because this point is clearance volume, that is fixed. So this point C is shifted to C dash. This point B is shifted to B dash. Now there will be re-expansion from C dash until the pressure becomes again even. Pressure is dropping when the gas is expanding. So ये भी जो दोनों lines हैं, those are following PV to the power n is equal to a constant. So in the first case, the induced volume was VA minus VD, but in the second case, for high pressure, वही single compressor है, single stage compressor है, which is used for higher pressure. Now induced volume is dropped because now this point is D dash. अगर आपका total volume same है, so it means VA minus VD was greater than VA minus V VD dash. Some issue with the eraser. So that was VA minus VB dash. So you can see the induced volume is dropped, right? Now, if we want to use the same compressor for even more high pressure till this point, let's name it P4. So it means that this compression should continue till this point, following the same equation, PV to the power n. So this is B double dash. Again, there will be delivery till this clearance volume, and then there will be re-expansion. So again, this point D dash is now further shifted to D double dash. So it means this induced volume is further reduced, V D double dash. So this is clear that as we are increasing the pressure, the induced volume is dropping. Is it clear? ऐसा ही होगा या नहीं? Okay, so hopefully it is clear. So that is the reason why if we want to use a single stage compressor for very high pressures, then the volumetric efficiency keeps on dropping. This volumetric, because of induced volume drop for the same swept volume, so volumetric efficiency keeps on dropping, right? Or ये एक negative effect है if we are using a single stage compression for higher pressures, then the volumetric efficiency drops. Secondly, what you can see here, as we shifted from B to B dash and then to B double dash, this temperature T2 at the exit is also increasing, T2 dash and T2 double dash, because more compression means more temperature at the exit of compression. Okay, so the gas will be leaving at a very high temperature when the pressure is higher, right? So this may damage the materials of the compressor. Maybe this temperature would be in an unsafe range, right? So that will damage the material of the construction. So that is the second major disadvantage of using the same single stage compression for very high temperatures, because we know temperature at the exit is given by this term, right? For a fixed T1, our temperature will increase with the increase in P2 by P1. Right? So temperature will also increase the delivery temperature. And secondly, ये जो चीज हमने यहाँ ग्राफ से understand की, the same thing is also can be understood with the help of this equation. This equation may be As the pressure ratio is increasing, volumetric efficiency will keep on dropping. So that is the mathematical expression that is telling us the same thing which we have demonstrated here in PV diagram. So that is the reason why we have to go for multi-stage compression, 2-stage or 3-stage, to achieve very high pressures. So for the low pressure ratios, we can use single-stage compression if this T2 is in reasonable range and volumetric efficiency is not that low. But for very high pressures, we have to shift to 2-stage or 3-stage, or in other words, multi-stage compression. So ये explain किया हुआ है इस slide में detail में, recorded lecture में भी और यहाँ. So that's why now we have to study the multi-stage compression. That the reason why we have to use the multi-stage compression. So just to improve the volumetric efficiency and just to keep the temperature at the exit of compression to a safe value. So it means now we are using 2 compressors. First compressor, this is P1. This is some intermediate pressure. This is not our desired pressure. Desired pressure is P2, but we are using 2 compressors, for example. Now the gas enters into a second compressor at this pressure, and then it leaves to our desired pressure P2. So now instead of using single compressor to raise the pressure from P1 to P2, we are raising this pressure in 2 steps. Okay, first from P1 to PI, and then from PI to P2, instead of one single stage. That is only 1 compressor, but now we are using C1 and C2, 2 compressors. So let's show it on the diagram, on PV diagram, this process. So let's start from the first compressor. So here is the induction stroke till this point A. Point A say so from this point A till point some B, compression in the C1 in first compressor, then B2, for example, this is point C. For first stage compressor, there is re-expansion. Okay, so here again, so now the gas will leave at this intermediate pressure, PI, this one, from C1, so that represents C1. And also here we are assuming that the delivery process from this first or low pressure compressor and to the second compressor, it is at same pressure PI. Actually, there will be certain pipe which is connecting these 2 compressors, and there is some pressure drop within this connecting pipe. So we are neglecting that effect. So it means we are saying it is leaving at PI and entering at PI in the next compressor. Okay. So now it enters at this pressure into the next compressor at the same pressure PI. Okay. So here A, B, C, D is low stage compressor. That is VC for low stage compressor, and that is VS for high stage compressor. Now it means the substance is now entering into the second stage compressor at a higher pressure. Same mass, जो mass यहाँ पे induce हुआ था, same mass is leaving the first stage compressor but at a higher pressure. ये जो mass है, जो low pressure पे हुआ था, now it is leaving at a higher pressure, PI, and now it is entering at a higher pressure into the second compressor. तो second compressor में जो mass enter होगा उसका volume कम होगा because pressure is already increased. So same mass but lower volume. So second stage compressor में it enters. So यही line will show the second stage compressor induction stroke. ये जो line है B to C can be represented for the induction stroke of second stage C2. Now we are going from C backwards to B. Now whether it will be B or not, it could be, for example, here, because we don't know what is the swept volume of the second stage compressor. So we नहीं है कि swept volume दोनों compressors का same हो. And normally Vs of second stage compressor Vs2 will be less than Vs1. Why? Because here same mass is entering at a higher pressure. Higher pressure means lower volume. So here we do not need as large volume as in C1, because here its volume is already reduced compared to C1. So that's why the swept volume will be lesser. So abhi main se explain karta hu. For example, it ends up here. Let's name it A double dash. Here it is the compression in the second stage compression. Delivery. Right. Now let's assume कि जो second stage compressor उसका भी जो clearance volume it is same as C1. That is C2. Now there will be a re-expansion, and this gas has left at pressure P2. So here is the swept volume, the induced volume for second stage compressor. Now the swept volume will be lesser than this one. So it means that this minus this should be less than this one for the low stage compressor. But we do not know what about the VC. VC of high stage compressor and VC of low stage compressor may be different. It may be same. अगर दोनों same है, तो at this point A double dash should have been here. Okay, ये जो swept volume है Vs of C2 should be less than Vs of C1. But अगर हो maybe its clearance volume is less. इसका clearance volume यहाँ पे हो, या इसका clearance volume इतना. So this point A dash could be here. This point A dash could be here, depending upon what is the clearance volume of the second stage compression. Because second stage का जो compressor है उसका design is different from the low stage compressor, because this compressor is compressing a different volume of gas. Same mass, but different volume. Because यहाँ volume definitely already increase हो चुका है. So that's why the design, the size of that compressor is normally smaller than C1. Why smaller? Because already volume is reduced. Right. So to compensate for the same mass, its volume should also be reduced. अगर इसका volume बड़ा होगा तो it means कि यहाँ पे further expansion हो रही होगी. So that volume should be less than this volume, right? So that उसका pressure drop ना करे, उसे PI पे रहे when it is entering into the second stage compressor. If its swept volume is more than the swept volume of this one, this pressure may drop because volume is increasing. So this volume should be smaller than this one. This volume should be same as the volume at which it is leaving the first stage compressor. Volume तो drop नहीं होना चाहिए. उसी volume पे it should enter, and then it should compress from that volume onwards to the desired volume corresponding to this new pressure. Right. So that has been explained. Recorded lecture में काफी detail में explain किया हुआ है here because we have less time, so I'm passing it a bit at a higher pace. So any question then ask. So now we are using two-stage compression instead of one stage, so that we can avoid the volumetric efficiency, the reduction in volumetric efficiency. Now this compressor has its own volumetric efficiency, this higher compressor, and this lower compressor has its own volumetric efficiency. But यहाँ दोनों के जो swept volumes हैं, both are different. यहाँ पे swept volume भी reduce हो गया. यहाँ पे swept volume वही है, but now in for the second case, swept volume is reduced. So that's why volumetric efficiency will increase. जब ये single stage compressor था, so then we had the same fixed swept volume for very high pressure ratio. That's why volumetric efficiency dropped. So now with this way, in this way, we can increase the volumetric efficiency by using two compressors instead of one. We can also go for 3-stage or 4-stage compressors depending upon कि ये जो ratio है कितनी ज़्यादा है. If this pressure ratio is even very high, we may go for 3-stage compression. So we have to do certain calculations before designing or before manufacturing such compressors for a certain application. Okay, 2-stage or 3-stage or 4-stage or 1-stage, which one is technically and economically feasible. यहाँ हमने अभी सिर्फ volumetric efficiency को discuss किया. The second factor was the temperature. Temperature, तो आप देखें, when this fluid which is leaving the low stage compressor, it is entering at a higher temperature. For example, this temperature is TB. Now it enters at the same temperature in the second stage compressor, because we are assuming here कि ये जो pipe connect कर रहा है two compressors को, there is no pressure drop, there is no temperature drop in these two compressors. So no temperature drop, it means कि it will enter at the same temperature. So वही temperature will further rise होगा. It means कि जो temperature वाला effect है, that is still not taken care of. Volumetric efficiency तो हमने improve कर ली by using two different compressors, higher stage compressor with lesser swept volume. But what about temperature? Temperature पहले यहाँ rise होगा, फिर उसी temperature से further second stage में rise होगा. So for that, what we do, we use cooling mechanism between these two compressors. ये जो fluid leave कर रहा है first stage compressor को, that is entering into a heat exchanger. It is cooled here. Here it rejects heat Q to some cooling fluid. So here its temperature drops. Temperature drop को मैं explain करता हूँ. For example, this is temperature line. This is the temperature line in PV diagram. This represents TA line. This represents TB line. Right. Right. Okay. Now it is leaving the first stage compressor at temperature TB. Inlet temperature कितना था? TA. This temperature is increased to TB. Now there is a cooling process. So let's assume कि यहाँ cooling इतनी हो रही कि its temperature again comes back to TA. So during this cooling process, this gas which is entering at this pressure Pi to the second stage compressor, its temperature is again TA, equal to TA, because there is a cooling between two compressors. So because of this cooling, this fluid which is entering into the second stage compressor is also at this temperature line TA. So this point A double dash is shifted here because of cooling process. Because the cooling करती क्या है? Cooling की वजह से आपका volume further reduce हो जाता है, right? So volume is further reduced. So this point A double dash will shift to this point. Now there will be compression from this point onwards. Because during compression temperature rises, but temperature अब यहाँ rise TA double dash से नहीं कर रहा है, इस point से कर रहा है. So it means Now this point is shifted here. So that is the area which we can save. That is the saving in work because of the cooling between two compressors. Because of this cooling, temperature drops, and ideally we are assuming इस point के ऊपर temperature is same as the initial temperature TA. उसी isotherm के ऊपर ये point है. And the compression starts in the second stage compression from this point onwards. So that is the second effect, the effect of intercooling, which will reduce the volume when it is in the same pressure, PI, pressure PI, but because of cooling, its volume is dropped, right? So the compression starts from this point onwards. So this is the area which we can save, because this area represents the indicated work input to the compressor. So here area which we can save by shifting this point from here to here. So यही यहाँ explain भी किया हुआ है in this slide. We have shifted this point to this point, and that is the saving in work input to the compressor, the second compressor. So isotherm should be clear how the temperature, because ये जो compression process उसमें तो temperature rise होना है. That's why you have a different temperature here, different here. Similarly, here you have different temperature TB dash, TB double dash. But now the temperature at the exit is TB double dash, TB dash, which is less than TB double dash. So that's why you can increase the efficiency by intercooling between two compressors. And also we can reduce the exit temperature, TB dash instead of TB double dash. For example, your temperature 500 tha. Now with this process of intercooling, we have reduced this temperature to, for example, 300 degrees Celsius. So इससे आपके compressor की life भी increase होगी, and we can also save some work input to the compressor. That is the reason why we use two-stage compression with intercooling. So आपने gas turbine के chapter में we have learned about this effect, but वहाँ इतनी detail में हम नहीं discuss कर सकते थे. For that we have to show it on PV diagram. Right? So I think now it is clear why intercooling with two-stage compression reduces the work input. तो question है तो पूछें इस टॉपिक का जो लिंक है वो आपके लास्ट चैप्टर से भी है, चैप्टर 4 से, where you are using in some cases वहाँ पे 3 compressors भी यूज हो रहे हैं with intercooling. यहाँ हमने भी डिस्कस किया 2-stage compression with intercooling. There could be 3-stage compression अगर यहाँ फिर इंटर हो फिर intercool हो, so further you can reduce the work input. But with this all, yes, hopefully it is clear. Here you can see that we are increasing the cost also. ये देखिए ये first stage compression compressor है, ये second stage compressor है, इसका आपको volume भी देख लें, that is smaller because here volume is already reduced, pressure is already increased, right? तो और वॉल्यूम रिड्यूस हो रहा है, तो यहाँ पे फर्स्ट स्टेज कंप्रेशन की वजह से, सेकेंडली ड्यू टू दिस कूलिंग इफेक्ट. सो हियर वी आर यूजिंग सम कोल्ड वाटर or some kind of coolant, could be cold air or any other type of coolant which is available, which decreases its temperature. So here you can see P1 T1 पे enter हो रहा है, PI higher pressure, higher temperature पे out हो रहा है from the first stage compression. Now it cools here, so pressure remains same, PI to PI, but temperature reduces from TI to T1. Now it enters into second stage compression. So high stage or high pressure compressor or high pressure stage, right? So here pressure again increases from PI to P2, temperature again increases from T1 to T2, not from TI to T2, T1 to T2. So there you can now install another intercooling, another compressor and so on. But this increase in efficiency with the inclusion of intercooler and second stage compressor is not free of cost. You have to pay more cost for such system to improve the efficiency. So that's why the economic factors are very important to decide whether to use 2-stage compression, 3-stage compression or not. So if economic factors dictate that we should go for 2 stage or 3, because the saving and work input is the main thing which will tell us whether economically that will be justified or not. Saving and work input over the whole lifetime of this compressor. Or जो saving and work input simply means saving in input energy or input fuel to run this compressor. Based on this, we have to go for double stage or 3 stage with intercoolers. Any question?
No, sir.
ओके इंटरकूलर में भी अब आप चैप्टर 4 में जो न्यूमेरिकल सॉल्व कर रहे होंगे वहाँ पे एक एक्चुअल टेम्परेचर होगा और मैक्सिमम पॉसिबल टेम्परेचर होगा. तो ये एक्चुअल टेम्परेचर यू कैन सी T1 माइनस Ti, और मैक्सिमम पॉसिबल क्या होगा कि ये T1 का जो टेम्परेचर है वो T ये जो वाटर है उसके इक्वल हो जाए. यहाँ पे रिड्यूस होने के बाद मैक्सिमम पॉसिबल कि ये T1 इस T ऑफ वाटर के इक्वल हो जाए. सो दैट इज मैक्सिमम पॉसिबल और एक्चुअल. ठीक. सो इसी बेस पे वहाँ पे आई थिंक एक टर्म भी यूज हो रही है, हीट एक्सचेंजर रेशियो समथिंग, हीट रेशियो. दैट इज बेस्ड ऑन दिस कॉन्सेप्ट ऑफ हीट एक्सचेंजर. ओके जी. सो जस्ट एक लेक्चर रह गया फ्राइडे को, तो हम ये कोर्स कंप्लीट कर देंगे ऑन फ्राइडे. सो जी. So any question related to anything, then ask.